Since the main recording, what I did, I modified the program that I presented to you, and now it does the it's called crank slider 1, and it does the simulation the way it's expected you to do it, and also open the DXF file in AutoCAD and show the mechanism in the minimum maximum transmission angle positions. If you want to, also required is to do the limit positions. If you want to do the limit positions, then and I'm going to show you, because it's a matter of accessing the code on the horizontal one, so you don't see right away my implementation of it. So I hit the escape key, escape, okay, and go to the other one that the slider moving in the horizontal direction. So if I want to, and you have to calculate, by the way, the angles for the angles for the limit positions using right angle triangle. Go to the notes. So let me first repeat, and then go down and say until it's 27, I believe. And okay, so let's see if it works. Looks like. So now it will continue running indefinitely, or until I press the escape key. And escape key, you need to bring this up and click on it, and escape key, and it is stopping. Okay, so if you want to show the mechanism in just one position and take it to AutoCAD, okay, you can do this thing. You can go from 1 to 1, so for loop was just one loop, and then you go and say theta 2 crank angle is going to be the angle that you want. So if I want to show the mechanism, my mechanism, for the crank at say 28 degrees, I need to have this in radians, so times RAD, or divided by, it's the same thing, DEG. Okay, so times, converted it to radians, and so it'll be now a DXF file will have just one layer, and that layer will correspond to the angle 28 degrees. Well, 20 degrees does not correspond to a limit position. That's again a matter of calculating it, so what would be a better value? Maybe 128. Again, you don't need to guess it, you calculate it. You calculate it using right angle triangles. It's something that or geometry is discussed in the notes, okay? So yeah, this was it. In addition to so again, I changed. You can either replace 73 with 1, or you just make it going from 1 to 1, just one iteration for the for loop. And then I want to go back to the put angle and explain it a little bit. So this is put angle for the transmission angle. Okay, so I need to specify, since I'm measuring from a vertical, I need to specify a point above B. So you will see y of B plus some number, and I chose that to be 2. Okay, and then the other, so it's an angle that goes from that point offset by 2 in the y direction, point B and point A. So let's look at the at it again. I have xb and yb plus 2, xb itself, and then yb. Let's see the effect of changing this to length of the dimension. You control it with, you can make it 20, does not show any difference as long as it's there. The effect of, or changing the length of that line, you do it with and it's at the what, not the dimensions of, but rather relative, in terms of relative dimensions. I'm telling you, it's in terms of diameter of the, or size of the joint. Okay, so this 15 has nothing to do with any dimension of the drawing. And I have a child crying, and I need to stop recording here. So we leave it 5, or was it 2 or 3? Yeah, if I make it, what, 8, it's getting a little bit bigger. All right, but this is just one position. If I open the DXF file, I'll have just one layer with this position. And of course, you calculate the angle for which the limit position, the minimum and maximum displacement S occur. And I'm expecting for the final project report, it's not mandatory. It doesn't mean that it excludes anything else about that project, but I'm expecting to see them created and introduced in the first part of the project. We'll discuss about the second part of the project, for which you have to select a belt and size some gears and draw a shaft. Okay, so recording stops, and I'll see you later.